Hi guys, welcome to Unacademy JEE English, a brand new channel by Unacademy, India's largest online learning platform for IIT JEE. Here, everything is taught to you completely in English. So the topic of today's video is electrostatics of a conductor, and this is part 2 of the video. In part 1, we already discussed about some basic properties of conductors, and in this video, we'll be discussing about some common configurations and how charge distributions happen there. Also, we'll talk about some potentials that and how to calculate them. Right. So before we get started, let me tell you a bit about myself. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and I have 7+ years of teaching experience. I myself was JEE rank 447, and I've coached many students in top ranks in. Moving forward, let me also tell you about the Unacademy subscription and its benefits. One, it comes with live classes. Second, you get to interact with educators. Then you have live polls and leaderboards. You got test series and analysis, very important for your self testing. Then you have live doubt clearing sessions. Trust me, the last 2 points will make a huge difference in your JEE prep. All right, and most of all, you have access to India's best educators. So, how to get the subscription? You can follow these easy steps. Find the Unacademy app, install that, go to the plus segment, select IIT JEE, click on Get Subscription. Now, when you're trying to get the subscription, you can use my code, which is RD Live, and get discount of 10%. Right. So let's get started with today's topic, statics of a conductor, part 2. So as I said, we'll be discussing some common configurations today. The first configuration that we discussed today is spherical configuration. There are so many questions which involve spheres, concentric spheres, and you are asked to find charge distribution. I know these questions can be really tricky and really painful. Let's try and make it easy today. Firstly, let's discuss the most simple case. You have a single shell. This single shell is given a charge plus Q. Now, how does that charge distribute on it? We already discussed in the last video that the inside of this shell will not get any charge, and the outer surface will have all the charge plus Q. Right? Now, how do you find the potential of this surface? Potential, is calculated with the formula equals kq over r. Now, in this case, how is the charge distributed on the outer surface? It will be distributed uniformly. Why so? Because remember, in last lecture we discussed when the charge is free to distribute itself, it follows sigma inversely proportional to r. Right? There is no external charge or external field influencing the distribution of charge. So, in this case, the charge will distribute itself so that the sigma at any point is in r. Right? And this being a sphere has the same R everywhere. So the charge everywhere gets distributed uniformly. Alright, then let's take a look at a slightly more complicated case. Now here you have two concentric shells. So the inner shell has a radius A and an outer shell which has a radius B. Let's assume the inner shell was given an initial charge of Q1 and the outer shell was given an initial charge of Q2. Now let's see how the charges start appearing on the surface. Let's talk about the inner shell first. The inner surface of the inner shell will not get any charge. All the charge given to it, that is Q1, will appear on its outer surface. Now, the moment that happens, a charge of minus Q1 will appear on the inner surface of the outer shell. Why is that happening? To ensure that the field lines of Q1 are not entering the volume of the second sphere. Now, charge conservation tells me that the outer surface of the outer sphere should get a charge of Q1 plus Q2. Why? Because the total charge on it has to be Q. So that is the charge distribution. Now, if you want to find the potentials at different points, so for the inner shell, what is the potential? It will be KQ1 over A plus KQ2 over B. Right? For any point inside the inner shell, what will be the potential? It will be the same. Well, last time we talked about this. That inside a shell, the potential is the same as that on the surface. So when I know the potential on the surface of the inner shell, I know that at any point inside the shell, the same. Right? How about the outer shell? The outer shell will have a potential of KQ1 plus Q2 upon B. Right? Now you can notice that this potential depends only on the net charge that is on the outer surface. Inner charges are not mattering. You will have to remember that. That will be very helpful. Right? Also, you will see that delta V is KQ1 over A minus KQ1 over B. And you will realize that the delta V between the two spheres is independent of the charge on the outer surface. Delta V will depend only on the charges inside, and the V of the outer surface will depend only on the charges outside surface. So remember these points for now. We'll use them later. Next, let's take a case of three concentric shells. Now you have three concentric shells of radii A, B, and C, and these are given charges of Q1, Q2, and Q3. Right? You can see in your diagram that the outer shell of the innermost shell of radius A gets the entire charge Q1 on its outer surface. So because of that, the inner surface of the middle shell gets a charge of minus Q. Right? Now, to allow charge conservation, outer surface of the middle shell will get a charge of Q1 plus Q2. This will result the inner surface of the outermost shell to get a charge of minus Q1 plus Q2. And again, in accordance with charge conservation, the outermost surface will get a charge of Q1 plus Q2 and Q3. So remember, whenever you're trying to see the charge distributions, remember one thing, that first of all, you always remember charge conservation, and second key point is that you always remember that the two sides facing each other will always have equal charge. So let's try and see the potentials at different points. Here I've shown you the potential at the inner shell, then the potential at the middle shell, and also the potential at the outer shell. This is simple to calculate. You should just look at it once. The thing that you will notice that delta V between any two spheres is independent of the charges outside those. This is also the case that you saw in the previous example. You can remember that. Now there are quick tips about finding the charge distribution. One was that you always start with the innermost sphere. Trust me, you start elsewhere, it will be very confusing. So you always start with the innermost sphere. You always know that whatever charge is given to the innermost sphere will only appear on its outer surface. Innermost sphere can never have any charge on its inside walls as long as there is no charge present inside. So always try and start with the innermost sphere and then move on following these two things. One, facing sides will have equal and opposite charges. Second, charge conservation will be this. Next, for writing the potential of any shell, consider only the charges that are lying outside the shell. All the charges lying on its inner surface and inside the shell, they do not contribute to the potential. Remember, we had discussed this in the last video, that when we talked about a conductor and charges inside the cavity. So no charges inside the cavity contribute or at any point outside the cavity. So that is the thing that we are using. Please remember these two quick tips that will help you find the charge distribution. Alright then, let's take up an example here. In this example, you are given three shells A, B, and C, R, 2R, and 4R. So you've been told that the middle shell B has been given a total charge of plus Q, and shells A and C were electrically. Let's find the charge distributions here. Let's talk about the innermost shell first. What was the charge that it had? It had zero charge. I know on its inner surface, it will again have a zero charge, and on its outer surface also, it will have zero charge. Right? Alright then, let's talk about an example and let's see how to apply what we have learned so far. Alright, so in this example, you've been told that there are three spheres of radii R, 2R, and 4R. We've named them A, B, and C. We've been told that shell B is given a charge plus Q, while shell A and C will. So let's see what charges will appear on what surface. Let's talk about the inner surface of the shell A first. Now, this in any case can never have any charge. And what is the total charge on shell A? It is also zero. That means the charge appearing here is outer surface of shell A. The charge on the to have to be equal and opposite, right? So this is also that charge on B was plus Q. Charge on its inner surface is with the charge on its outer surface. Outer surface will get the entire charge of, right? Since this gets entire charge of plus Q, inner surface have to get charge of, right? Right? Sides will get. Also that shell C also was neutral, right? Since that was also neutral, so what is the charge that should appear on the outer surface of this shell? This, right? Right, why? That's the total charge on it. The next part, what you've been asked is, you've been asked to find the potential difference between the innermost sphere and the outermost shell, right? Now, all you need to do is actually find shell B and C, and that will be the same as the potential difference between shell A and C. Why so? That is because shell B and shell A will be the same potential. I say that, you realize there is no charge here anywhere, no charge here, right? So that there will be no electric field in this entire region. There is no electric field in this entire region. All this region will potential of B will be same as potential of. So now that I know that, so it's time to find the potential shell B and shell C. So I know that is going potential at shell B, that going to be A Q bar, and what is going to be potential at shell C? That will be, and this is also equal to potential at shell A. So that shell C will have a potential A Q, right? This depends only on the outermost charge only. So once you have these, the delta V between A and C. Hope this was easy. Everybody followed this? Alright then. Let's move on. Let's talk about earthing of a conductor. Let's talk about what do I mean by earthing. When I say earthing of a conductor, I mean the conductor is being connected to earth. That is what earthing means. Symbolically, we represent it like this anywhere with a conductor. You know that conductor has been or connected to. So let's talk about that. First of all, I know that earth behaves as a conducting sphere. Why is that? Because of vast amounts of metals inside. It will always behave like a conducting sphere. And since it is a conducting sphere, I know how to calculate its potential. Potential of a conducting sphere will be dq over r. The charge on it, and r is the radius. Now, how much total charge do you think Earth has? Some of you might say it has zero charge. That's not entirely true. Fine, it should have zero charge because it will be neutral. But you remember, we are going on connecting charges with the Earth. We are earthing them. And there might be charge exchanges happening between conductors that are connected to the Earth and the Earth itself. Right? So these two will exchange some charges. So that may result in the Earth gaining a net charge. However, any practical charge transfers are of the order of 10 to the power minus. Right? That I told you earlier. You guys already must know that practically the charges exist in microcoulombs. Even in all your problems, you talk about nanocoulombs, microcoulombs about it. So even if through all these interactions, Earth has accumulated a net charge, that charge will be of the order of 10 to the power minus 6 coulomb. And what is the radius of Earth? It is roughly 6400 kilometers. Right? So that is of the order of 10 to the power plus 6. Right? When you try and find out the potential using AQ over R, potential will come to be of the order of roughly 10 to the power minus 3. For all practical purposes, I can say that potential of Earth is 0. And no matter how many more charge exchanges are going to happen between Earth and other conductors, potential will remain 0. Because practically the total charge built up on Earth will always be in microcoulombs. And the radius is very high. So potential of Earth will always be 0. That is why we consider putting Earth to be an equipotential, a surface of constant potential. So, since Earth is a conductor which has a constant 0 potential, when I connect any other conductor with it, will be the potential of that conductor, it also exchange charges with this, so that its potential will also come down. And that is what you mean with earthing. So what will earthing do? Earthing means you will connect a conductor to the Earth. When you do that, the conductor will exchange some charges with the Earth and it will make sure that its potential comes down. Right? Let's see the effect of this. So here I'm discussing single shell, and it initially had a charge of plus q, and now it has been corrected. Now we are to calculate the charges appearing on happen. Inside surface I already know can never be any charge. Charge here is, now let's assume it takes a certain charge x from, so the total charge on the outermost surface will be capital Q plus capital. Second thing I know about earthing is, and when anything is connected to earth, its potential come down. If I try and find the potential of this shell will be a q plus x over r, right? So since that is 0, what I get is x equals q. The net charge here will be, entire charge q would have flown down to the earth. When you connect a single shell earth, all its charge will float and it will become electric. Now that is also the basis of earthing all your electrical appliances at home. Also seen the earth wire, all the electrical appliances at home are earth. That's the logic of it. So in any case, you know, most of your electrical appliances like your television or your fridges may have metallic surfaces, right? And those metallic surfaces may have accumulated certain. And if those charges remain there, when you touch those bodies, you will feel a shock. Must have happened to you on cold mornings, dry cold mornings. Sometimes you touch the fridge and you get a shock. That is due to some charge accumulation happening there. So what does earthing do? Whenever you earth such an appliance, all the charge, if at all, any has been accumulated, will flow down to earth. If this happens, right? In that case, you will not get that. That's the logic of earthing your appliances. Next, let's talk about two conductors, and here the outer shell has been earthed. Okay, so I've been told that the inner shell was initially given a charge of iron, and the outer shell was given a charge of how the charges are. So here, the innermost surface, I know the charge will be 0. No matter what happens, connected to Earth, as long as there is no charge inside of this shell, charge on the inner surface will always be. Now this guy had a total charge of plus q1, and since this is not connected to Earth, so its total charge cannot change, right? So all the q1 will appear on the outer surface. So if plus q1 comes here, minus q2 will have to come here. Now this is a must, no matter irrespective of whether there is earthing or not. This will always happen to ensure that the inside conductors is 0, right? Now, the outermost shell initially had a charge q. So this minus q1, another plus q2 should appear on the outer surface. And let's assume that it takes up another charge x from total charge on the outer surface plus q plus x. Now, all I need to do is also use the fact that the potential of this shell, which has been connected to Earth, would be 0. So which means k q1 plus q2 plus x over b must be x plus, or you can say is the entire, right, plus q2 would flow. And since q2 was already present on the sphere and q1 has also flown to Earth, so it is left with a total charge of -1, which comes on its inner surface, and eventually the outer surface will have a net charge of 0. Right? I hope everybody followed that. So notice this, that whenever the outermost shell is being earthed, the charge on its outer surface will always become, irrespective of how many shells are there. Even if you had like 6 shells, 7 shells, concentric shells, the moment you earth the outermost shell, charge on its outermost surface will, remember that quick tip that will help you save a lot of time, right? And next, let's take up an example. All right, so in this example, you've been told that there are 3 spheres of radii A, and they are given charges of q1, q2, and find the charges appearing on all the surfaces if the outermost shell is connected. Right? So, as always, we always start with the innermost shell. So, innermost shell, I know that the inner surface of this shell will get. And what is the total charge it had? It had q. Now, since this is not connected to anybody, the entire charge q will The moment Q1 comes here, charge of Q1 will come over inside surface of shell, since minus Q1 comes here, and the total charge on this shell was charge of plus Q2 will appear on the right. Since plus Q1 plus Q2 is appearing here, happen to the inside wall, will have a right. Everybody following that? Now, what about this charge on the outermost surface? You can start assuming some charge, use the fact that potential and calculate it, or I immediately know. Just talked about this. The moment outermost shells are connected to Earth, all the outermost surfaces will automatically for this trick will help you sometime. Right. Forward. The next configuration which we will discuss is parallel plate. Again, a lot of questions. This come in JEE. So be very careful and listen to everything. Alright, for my first case, I've taken the simplest example of a single plate. Single plate has been given a charge of total capital Q, and we want to see how it appears on the two faces of the sheet. Now you realize that we assume that no charge. Alright, so the first case that we are going to discuss is a single plate. Here I've taken a single plate, I've assumed it was given a total charge of capital Q, and I want to see how this capital Q on the. You need to know one thing, that before starting any calculations or starting to find out any charges, it's an assumption. Make an assumption that the thickness of the plate is negligible. Thickness is negligible for because of this. For all practical purposes, I can consider these sheets as finite. Right, that's the assumption. That the dimensions of these spaces on either of the sides of the sheet are so huge that these can be calculated, assumed to be infinite for all calculation purposes. And because this thickness is negligible, so this is negligible, and that is why see, that no charges will appear here. That is why I'm not considering charge accumulation on these two. So the charges are coming on the side sheets. Right. So here I assume that charge of plus small q comes here, charge of capital Q. So how much is small charge Q? I need to follow just very small. I need to remember the fact that inside a conductor, let's take any arbitrary, take any arbitrary point here. Field here must be. Now the field here is being caused by the sheet and this direction. Now for it to be zero, these have to be equal. Now the only way these two fields place is these sides had equal. I'll tell you that charge of you will get you could have also said that using this argument. So if charges, let's say Q1 will have to come on one side and Q2 will have to come on the side, I said there is no reason why one of these sides should have a greater charge. Why? Because everything is identical for these two sides. So symmetry, I can say that the charges on both these sides should. That would have helped me come to this conclusion directly also. That both the sides will get Q by 2 charge. Right? Moving forward, let's take up a case where there are parallel plates. Right? So I've assumed in this case that there are two parallel plates facing each other and they are given charges of capital Q, capital Q. And I've assumed that the charges appearing in different surfaces are as shown. Assume that small q1 appears, giving capital Q1 minus small q2 appears. Now all I need to do is find out the. Now one thing that I'll know is that I remember my approach here will be one condition is very important, which is that the electric field inside the conductor, which means I take up electric field, using those I will get the result that if this guy charge of this sheet will always the case. No matter one face is charge q facing side, which will take up an equal and opposite. Right? Now the net charge held by these two is, I will also conclude that if this guy takes up a charge of dash, then this guy will take up a charge of q dash as well. We'll look at the proof. As of now, remember this. Whenever you have two parallel plates which are inside sides are facing each other will always get equal and opposite. The outside side will get equal amount of charges both in magnitude and size. I already know what is the net charge on the inside of the two, which means all the charge getting distributed on the outer surfaces. How much charge did I have to start with? This q plus q2. This q dash must be 1 plus by 2. Same goes. Both these sides will get half of the total charge. Right? So remember this. So these are very important facts when you find out charge distribution. One, facing sides will get equal and opposite charges. Second, outside sides, both the outside sides, there will be always two ends, any kind of configuration. Both the surfaces on the outside ends will have half of the net charge each. Half of the net charge will appear here and half of the net charge will appear here. And inside every facing sheet will have equal and opposite. Remember these 2 points will help you determine your answers. So okay, let's talk about the proof. Can be let's start by assuming that every sheet is different kind of a signal. Let's assume charge density here is charge density side is sigma. Charge density. Now I know that here and here, any point inside these two. Now let's try and make a better view of the slightly broad. What kind of field exists? In this region, I know that the field has to be either in this. But what I know for sure is that it will be perpendicular to both the sheets. Right? You'd already assumed that both the sheets to be infinite. An infinite sheet produces electric field to itself. So now, if I consider an arbitrary Gaussian surface, consider a cuboidal surface. This cuboidal Gaussian surface will have 6 sides, 2, 4 on the other side, top 2 and 2 against the faces. Right? So what about the faces which are here? These faces, I know the face vector will, what will be the angle A vector and E vector 90. Same happens for this face, A vector. I know for side faces, side face, can I say of E? Can I say that? Because E and dA all. And how about the two end faces? This will also be 0. Why? Because the E at these. Why? Because these faces are lying inside the volume. Also, side faces will E for D. The main is 0. So what I find is for my dot dA is the charge enclosed. Charges in, if I assume this area is there is all. The charge enclosed, 2 enclosed, 1 A. I get is that's my first conclusion. Facing sides will have equal. Now, since the sigmas are equal and opposite, Alright, so this is the conclusion that I get. The sides which are will have equal, hence equal charges. Right? So that's the first part of the proof. Now next, I said that the charges here are that I consider a point inside this. So let's try and find out what are the fields at this point. So let's assume this guy had a charge Q, and obviously charge of minus. Let's assume this guy has a charge of capital. Guy has a, so this point there will be, right. So I already know. Let's talk about this surface. Let's say its field is even. It will be even. And due to this, let's assume what will be the direction of, right? Why? Because this is negatively charged. And I also know since the magnitudes of both the charges are equal and the sigmas on the plates are equal in magnitude of even will be equal to that mod of even, mod of equal. The directions are opposite, which cancel each other. The field of this guy and this side that is getting cancelled by the field. Right. All I need to do is now get the. Let's talk about this sheet. So since this had a charge density of sigma 1, will be the field here, this here due to this sheet, sigma 1 over. This guy now had a charge density of, due to this, this direction, 4 over. Now these two are already pointing in opposite directions. All they need to do is cancel each other out, be of equal magnitude. So that will tell me that sigma 1 should be of both the charge density. Like the magnitude of both the charge densities must be that the charges appearing on the outer surface. Finally, what is the conclusion? Sides facing will get plan the charges, right? Sides on the outermost side have, right? I hope you guys can see. Have a charge here, charge here, charge on the outside is, right. Full proof. Go through this again and try and understand. Now, let's try and solve an example from what. So in this case, I've been given 3 sheets, right? And 3 sheets are given charges of plus 3 coulombs, and plus 5 coulombs. You've been asked to find the charge distribution. Now remember this while solving, that no matter how many sheets are there, any two facing sheets will have to have equal and opposite. The simple logic or the same proof discussed earlier. Take any two sheets and take a Gaussian surface like that. So it will show you that any two sheets have equal. Since all these guys have equal charges, starts bearing on the inside surfaces, which means whatever the net charge on all your sheets, all of it comes on the outermost surfaces. And we already realized both the outermost surfaces get equal, which means the moment you have any question, you find the total charge on all the sheets, and half of that will appear on the outer side of side, and half of that will appear on the other outer. So in this example, what is the total charge? It is plus 6 coulombs. So if the total charge is plus 6 coulombs, I can say that this side will get a charge of plus 3 microcoulombs. And similarly, this side will get a charge of, right? So that's the first step that you're going to take when solving the, find the total charge, put it half on one side, the outer plate of one side, and half on the outer plate of the other side. Now let's talk about charge conservation. Right. So let's talk about the plate 1 here. This has a total charge of microcoulombs and a charge of 3 microcoulombs already here. So what is the charge left on it? This phase gets zero charge. What is the charge that this phase should get? Zero. Why? Because facing sides. These facing sides must have equal. Now, what is the total charge on this? Total charge on this was minus 2 microcoulomb. And charge here is, so charge coming here would be minus 2 microcoulombs will appear here. So since minus 2 microcoulombs appears here, the charge appearing here plus 2 microcoulombs. Alright, and plus 2 microcoulombs here, and you will already see that plus here resulting in a total charge of plus 5 microcoulombs. Right, I hope everybody followed this. Remember two steps. The summation of by 2 on outermost charge and equal and opposite charges on face. Next, again, whenever you're solving the problem, firstly put the charges here on the outermost. Now start solving from this direction or either of the end for that. Start solving from. So take a one end and start solving for that using conservation of charge and using the fact that facing sides must have equal and opposite charge. That is how you can get these charge distributions easily. So after watching this video, please try some problems on your own and find these charge distributions. Right. So let's go over the checklist of problem solving once again. 1. If you have spherical configuration, then always start distributing charges from the innermost shell. 2nd, the surfaces facing each other will always get equal charges. 3rd, use conservation of charge to find their values. Right? Then earthing. The moment something is earth, it's connected to earth. Not. Alright, so finally, let's go over a checklist for problem solving one. First, if you have spherical configurations, remember always to start with charges starting from the innermost shell. These are the easy. The moment you have charges on innermost shells, use things. 1, that facing sides must have equal and opposite charges. 2nd, use conservation of charge. And from there, starting from the innermost shell, you can find out charges of different surfaces of different. For these two, start with innermost shell, use conservation of charge, use the fact that facing sides will get equal and opposite charge. Alright, next, in case there is earthing, in that case, do not apply conservation of charge, please. Many a times you guys ignore that. You see, earthing has happened, although you're still trying to apply conservation of charge. Remember, the moment conservation of charge will not apply so, because now it can exchange charges with earth, so net charge can change. So in such cases, what to do? Assume it takes some charge x from the earth and you solve for that x using the fact that the potential of this surface must. And we already discussed one common result. If ever outermost shell was connected to earth, then the charge on its outermost surface will always be. For that also, that's gonna use calculation. Next, how about parallel plates facing each other? For parallel plates facing each other, remember two things, very important things. Firstly, what you need to do, calculate the total charge in the system. Doesn't matter 2 plates, 3 plates or 5 plates. Calculate the net charge on all the plates. Then what do? Then you distribute half of this on one of the outer surface and half of this on the other outermost surface. So look at the two outermost surfaces, this charge half of everywhere. Then starting from any of the end plates, what you do is start calculating charge on the inside surface. Then you use the fact that charge here and charge will use that, then charge conservation, find the next charge and so on. Alright, that is how you're gonna do it. So, alright, that's the end of today's video. I hope you liked it and I hope this will help you with problem solving. Do solve some problems. and let me know how it goes. And let me again tell you about the steps of getting the Unacademy subscription. There are easy steps. Get the app, select plus, select IIT JEE, click on get subscription, and while getting subscription, choose and select my code RD Live to get an instant 10% off. Remember to use RD Live. Alright. Finally, if you like this video, please share it with your friends and also hit the bell icon. Right? That'll be it. Finally, one more time, my code is RD Live. Get 10% off immediately using that code. Thank you so much.